So in section 7.4, we're going to look at some additional operators. And the first thing I want to do is look at this Laplace transform. So we know that this is just a shift from s to s minus 1, because the coefficient there is just 1, which would just be negative Laplace transform. Oh, I'm sorry, I dropped my negative out front. Negative Laplace transform of t, and then after we find that, we go from s to s minus 1. So the Laplace of t is just 1 over s squared. We have that negative out front, and then when I do the shift, it becomes negative 1 over s minus 1 squared. Now if we look at the derivative with respect to s of the Laplace transform of just e to the t, then we're going to take the derivative of the Laplace of e to the t is 1 over s minus 1. So that's just s minus 1 to the negative 1 power. So when I take that derivative, I get negative 1 times s minus 1 to the negative 2 power times 1, which is just negative 1 over s minus 1 squared. So using the shift and then just taking the Laplace, we're getting the same thing no matter which method that we're using. So that's the next theorem. And it's the derivatives of a transform. So our theorem states if f of s is a Laplace transform of f of t and n is equal to the natural numbers, so 1, 2, 3, so on, then the Laplace transform of t to the n f of t is equal to negative 1 to the nth power, and then you have to take the nth derivative of f of s. So it just gives us one more way or one more method to solve for these Laplace transforms. Now, the one drawback is, if you can imagine, if my n is like to the 5th power or 8th power, that's going to be really messy. So I may not really want to use this method if I have big powers of n, but if they're not too big, then this method works fine. So let's look at an example. I have the Laplace transform of t squared e to the 3t. So in this case, my a is equal to a negative 3. My shift is going to be s minus 3. And my n is equal to 2. So I'm going to take the Laplace transform of t squared, which is just going to be 2 over s cubed. And then when I do that shift, I get 2 over s minus 3 cubed.